In this video, we are going to continue our discussion of register interference graphs and talk about how to use RIGs to come up with register assignments for procedures. And we're going to look at one particular technique that's popular called graph coloring. So first, a couple of definitions. A graph coloring is an assignment of colors to nodes such that the nodes connected by an edge have different colors. So if I have a graph, let's say with three nodes and it's fully connected, so every node is connected to every other node, and then a coloring of this graph would be an assignment of colors such that every pair of nodes that are connected by an edge have a different color. So for example, I could color this node blue, and I could color this node green, and I could color this node black. Okay, and then that would be a valid coloring of the graph because each pair of neighbors has a different color. And then a graph is k-colorable if it has a coloring that uses k or fewer colors. In our problem, the colors correspond to registers. So what we want to do is to assign colors or registers to the graph nodes. And we're going to let k, the maximum number of colors we're allowed to use, be the number of machine registers, so the actual number of registers present on the architecture for which we're generating code. And then if a register interference graph is k-colorable, then there's going to be a register assignment that uses no more than k registers. So let's take a look at an example rig. And for this particular graph, there is no coloring. It turns out that it uses fewer than 4 colors. But there is at least one 4 coloring of this graph, and here it is. So I've used colored labels, but also register names, so that you can see what registers we might assign to each of the nodes. And just notice that although there are many more than 4 temporaries or 4 nodes in this graph, we do manage to color it with only 4 colors, and some of the nodes have the same color. So for example, D and B are allocated the same color as are E and A. Just to remind ourselves where this register interference graph came from, here is the original control flow graph again. And once we have the coloring of the graph, now we can do the register assignment. We can replace the temporaries by their corresponding register names, and then we get this control flow graph. So here we've just renamed each of the variables in the program with its register that it was assigned to, and now we're very close, as you can see, to having code that we can emit and execute on the target architecture.